pressure reducing station for that building. There's my tags from last time, set at 30 psi. So we're going to come in here, we're going to shut our valve off there, shut our valve off here. Basically shut down this whole station, shuts down that whole building over there. Reducing station number 2. We're going to do the same thing. These feed only the buildings, only single building for heat only. So the other building I got to do is going to be a little bit different. And we'll go over that shortly. But we'll get the steam shut off and let this cool down for a little bit. And we'll go over and drain the other building while this sets off for a little while. Back on, the air will bleed, now get steam through, and all this will be clean. Now we can flush them when we turn the steam on, but that's what I'm going to do for all of these. So here we are, last pressure reducing station. Same deal. This is why they had all the issues in the beginning. They had all the air vents closed. Probably worked for a little while, except for the fact that all of these actuators were controlled off outdoor temperature and set to 50 degrees. So anything above 50 degrees, actuator would close, and then the condensate would back up in the air handlers. So we successfully lowered the pressure, but the problem with turning these off like I did the others, I need my low pressure steam, and we're running about 30 psi right now, because that feeds here, which this is a heat exchanger that my hot water comes through. Pump. So that's the valve that controls the temperature of the water, or controls the steam to control the temperature of the water. I can't shut the steam off to this, and it's fed from this pressure reducing station. So this is not domestic hot water. It is actually for an air handler that I'll show you here in a little while. Downstairs, it's a VAV system for the office area of this building. Instead of electric reheat on the VAV boxes, they have hot water to heat the space if they get a heat call. The only thing on this building that's keeping me from shutting this steam off is my hot water, or my steam going to make my hot water. I got a valve here that feeds down into the building and everything else. So I'm going to shut this valve and still use my high pressure steam going that way to heat my water. And we're taken care of. So last time they shut them off here, which did the same job, except it lost water to my hot water coils, and then I was out trying to figure out why I didn't have hot water. So we're going to shut this big guy off, and then we should be good in the rest of the building. Alright guys, so I'll show you a little bit of what I got going on here. We have kind of an unusual setup, but already changed the filters and rinsed the evaporator coil. Actually, that's not the evaporator coil, that's a separate water coil that's not connected. This is the actual BX evaporator. That's for water. This is a water source heat pump. We have 4 stages. I'm guessing about 20 ton, 25 ton a piece. There's our coaxial coils, our expansion valves. These stages are controlled by supply and return water. So we have a chiller in another building over here, but these actuators here control the water flow for the condenser. And we're trying to maintain basically, so this is my circuit A that's running right now. It's trying to maintain this 95 degree discharge saturation. And you can see we're at 98 right now, so it's going to start ramping up. And it's going to try to just modulate and maintain 95 degrees. This is a digital scroll, so when it gets closer to temp, around about 14 amps, when it gets closer to temp, it'll actually unload with the solenoid on the side of it there. And stage 1 will start to unload, and then it'll bring consecutive stages on as needed. So we're just doing a little bit of maintenance. Like I said, clean the evaporator. We've got exhaust and supply fan VFDs. This is a VAV system. Here's my duct static that I'm maintaining. We got 2 7.5 horsepower supply fan motors. Behind this duct right here is my economizer, outside air damper. Well, actually dampers in right here, but that's actually the outside air. It works just like a normal economizer, opens when the temperature will allow and tries to cool. This is our exhaust air out, and that's helping maintain building pressure, and then my return air in. So this is the backside of the coil, the water coil not being used. So we'll go through this control a little bit more, but for right now, let's get it cleaned up a little bit. We're going to clean the drain pan, and what we're going to do, because we are on our spring PM, we're going to shut each one of these circuits off. We'll have to shut the thing down first, and we're going to pull strainers and clean the strainers. That's going to be my condenser cleaning for this unit. We have had some crap in between shutdowns and everything else that these strainers get some crap in them, so we'll pull each one and get that done. We do have a manual. See that little knob in the middle there is a manual adjustment for that actuator, so I can actually use this little Allen key, spin it, and close the actuator, lock it closed with the unit off, of course, and then ball valve the supply off and pull my strainers. And we're still running off just circuit A. I do have a clear sight glass. We got oil at the compressor. So that's a good sign. Everything looks good. Still just monitoring my amp draw. We're 14 amps. And you can see that we've evened out about 43%, and that's maintaining at 95 degrees at 296 psi. So this is our control panel here. These are all the logic controllers, and they're communicating to all the VAV boxes as well. This is my comm link to building automation. It's all tied back into a main computer. Transformers, fuses, these are all the relays for whatever it may be. We got solenoid contactors, supply return fan contactors. These are my compressor A, B, C, and D contactors, and overloads. These are I got those labeled the fuse blocks for each, and fuse blocks for supply and return fan. Not a bad little setup. So we got the unit shut down. We got some junk in our drain pan. Just kind of like the IntelliPack on the previous video. Top coil drains into here. and then down into the main. There's all of our TXVs. Everything looks good. We'll go back through there and just make sure nothing's rubbing as usual. This unit's been here for probably about 5 or 6 years and haven't had any issues with any refrigeration circuits. So we're gonna start by just getting in here and blowing any crap out. Clean the back side of this evaporator. It's pretty clean. So we're just going to rinse everything down and out. Viper hand treatment. Rinsed all that stuff right there in my trap, so it'll focus kind of. So last thing we're going to do is just rinse down the trap. Make sure we clean the drain line and the trap out real well. Flush for a minute, and then that's going to be good. We'll move on over to our motors. So these are my return fan motors. We're going to wipe down the backs of them. I said return fan, I said that wrong. These are exhaust fan motors. And they had a spill up above us, which is some of this crap that you're seeing. But we're going to wipe these down real good, and we're going to get the blower in here and blow all this crap out, blow the motors, and we will get some grease on the motors. Be very easy with the grease. There's no ports on the bottom of these to remove. If they had a port like that, you'd want to remove it, then add your grease. And just be careful because you can easily over grease these motors. Just a pump or so is all you need. Very slow and deliberate so you don't bust the seal on the motor. So we're going to get that done, blow this out, and we're going to do the same thing over here on our supply fan motors. They're looking a little bit dirtier, some crap on the back of them. So we're going to get all that done, wipe the motors down, blow these sections out, and then go from there. So all that's done. One thing I didn't touch on while I'm in here, actuators. So I'm checking all of my linkage at the same time as I'm getting in there. So all the linkage is good. Motor's got grease on them. That's our exhaust actuator there, damper going to the exhaust air out. This is outside air right there, and my damper sits up top here, right there. So let's get over here. Everything's about good and clean. We'll start this guy back up. But last thing I want to do and make sure of is VFDs. We want to make sure we are going to turn the power off, let them sit for a minute. We're going to blow these VFDs out as well. There's fans on top of here. Fan blows through to keep them cool, so we want to make sure they're all clean and good to go. We don't have any issues with those. So we got this guy up and running. We're just monitoring here. We can basically check everything right from our control. So suction superheat, 14 degrees, 120 psi, that looks good. That's circuit A, that's my variable speed. Let's see here, the condenser, circuit A, maintaining that 95 like we talked about. Circuit 4 is the other stage that's running. It's still finding its way, so it's kind of modulating back and forth, trying to hit that 95 mark. Looked at that. B and C aren't running right now, so circuit D, we're running 20 degree superheat. It's kind of floating around. Probably it's still floating with that head pressure trying to find its way, so it'll all even out. And but for right now, everything looks good. I don't see any major issues with this thing. I'm going to check the other two stages, but I don't see any reason to actually pull the strainers at this point, because I'm maintaining at a pretty low percentage, maintaining that temperature. You can see my damper back there, so that one's, at about 20-30% as well, and I'm able to maintain, so I got no problem with that. Probably going to go ahead and just bring a bucket up here and flush them, just to make sure. If I see anything crazy come out, I might pull them, but at this point we're going to check the other two stages and call this one good. Alright guys, so that's going to wrap this one up. As always, thanks for watching. Got this guy buttoned back up, quieted down a little bit with these insulated panels, so leave me a comment, let me know what y'all think. Like and subscribe. Leave the tray better than you found it. We'll see you guys on the next one.
Oh,